Question 3. An electric kettle transfers energy at a power of 2.5 kilowatts. The kettle takes 160 seconds to heat 1 litre of tap water to boiling point. Determine the efficiency of the kettle. Energy needed to boil 1 litre of tap water equals 360,000 joules. Okay, so there's several stages to this question. First of all, let's get the units all in the correct form, because we've got power there of 2.5 kilowatts. Now, as we know, kilowatts isn't the unit we use in our formula or in equations, so therefore we'll convert that to watts. So multiply it by 1,000 to give ourselves 2,500 watts. Now, what we're now going to do is apply it to an equation, so we can say that power, which is 2,500 watts, equals energy divided by time. Now, we know time, we're given 160 seconds there. So we can now rearrange that equation to give us energy. So the energy is going to equal, the energy equals 2,500 times 1,600. So we've rearranged that equation to make energy the subject. That gives us an answer of 400,000 joules. Now, we've got that energy value. We know the energy needed to boil 1 litre of tap water is 360,000 joules. So to work out the efficiency, all we have to do is do the useful energy, which is 360,000 joules, divided by the energy used, which is 400,000, multiplied by 100, because we can see we need a percentage as our answer. And that gives us an answer of 90%. So it's 90% efficient. Now, just having a look at those numbers, that makes sense, doesn't it? Because we've got 360,000, we've got 400,000, 90% of 400,000 is 360,000. So we can see that efficiency is correct. I always think it's useful with equations like this. If you've got one where it's kind of a relatively obvious ratio percentage, you can just sort of work out in your head as well, just to see, does it look right? Clearly there, if we got a really different percentage from 90%, that would have told us that maybe we've done part of the calculation wrong. It'd be a good opportunity to go back and redo it, to relook through our working. Never just write the answer down. Always go back and think, does that number seem right? Does it seem in the right kind of realm of what the answer should be? And if not, go back and check your working to make sure you haven't made a mistake. Okay, so in terms of how the marks are allocated for this question, we have 1 mark for that initial equation there. We have 1 mark for the rearrangement. We have 1 mark for this here. We have 1 mark for the 400,000 joules, and then 1 mark for that equation, and then 1 mark for the final answer. That gives us the 6 marks available for this question.